Welcome everyone to another class of ETE 411 Renewable Energy. সবাইকে আমার ভয়েস ক্লিয়ারলি শুনতে পাচ্ছেন এবং লেকচার পিডিএফ দেখতে পাচ্ছেন? লেকচারটা দেখতে পাচ্ছেন? একজন একটু মাইকটা অন করে বলবেন। সবাইকে আমার কথা ক্লিয়ার শুনতে পাচ্ছেন এবং লেকচার দেখতে পাচ্ছেন?
জি স্যার।
আচ্ছা, ওকে, থ্যাংক ইউ।
জি স্যার।
Today we will learn about the topic that is called solar insolation. So what solar insolation means and what is the reason behind learning this topic? আমরা এই টপিকটা কেন পড়বো এবং কেন why it is important. So first of all, whenever you want to design a PV cell, you must know that how much of energy you are getting from the sun, and that is how you can design. Suppose that you have to live 1 month in a certain house and you have to ration yourself. You have to ration yourself and you can't go out for 1 month. So what you have to do for the beginning of the month, you have to buy produce, buy groceries, buy vegetables, buy your proteins. That is how you will plan for 1 month. So before the month you need to buy these products in order to survive. So whenever you want to design a PV cell, you have to know that how much energy you are getting in that place. That is how you can design your PV cell, that how much will be the length, how much will be the width, what will be the material you are making the PV cell. So that is why to know that how much power you are getting from the sun is very important. Because suppose you have 30 apples, then how you can survive for 1 month? Then you will divide that 30 apples. You will divide that 30 apples by each day. প্রত্যেক দিনের জন্য আপনি 30টা অ্যাপেল ডিভাইড করে নেবেন. That is how you will survive. Now proceeding, দেখেন যে সোলার ইনসোলেশন যখন আমরা শুরু করতেছি, we actually trying to understand that how much energy we will get from the sun. First of all, we will understand the topic name spectral irradiance. What spectral irradiance means? Spectral irradiance means that the amount of power you are getting per unit wavelength. The amount of power you are getting per unit length. That is called spectral irradiance. Sometimes it is called solar insolation. Whatever you may call it, that is you don't you. Now, for spectral irradiance, it is actually called that how much power you will get per unit wavelength. Wavelength means holo torongho doirghyo. What wavelength means? That each energy bands has certain wavelengths. Okay, so suppose there are wavelengths that for the UV cell, there are wavelengths for the visible ray, there are wavelengths for infrared. Okay, so for each of these wavelengths you will get individual power. Now each wavelength of the solar electromagnetic, these are all electromagnetic radiation, has a distinct power level. Each wavelength of the solar electromagnetic radiation has a distinct power level. Again, for each wavelength there are distinct power levels. Some power levels are high, some power levels are low, some power levels are in the ultraviolet region, some power levels in the visible ray region, some are in the infrared. We don't see UV and infrared, we only see the visible rays, which are in the range of 400 to 700. So this is a graph for the spectral irradiance, and this is if you see the unit, you will get it that this power is for the unit wavelength and unit area. Now you don't want the power for unit wavelength, you want the power for the whole region. You don't want it for 1 day or 1 meter square or 1 unit wavelength. Now how you can find the accumulated effect of all wavelengths together is insolation. খেয়াল করেন, the accumulated effect of all wavelengths together is the insolation. You remember that the insolation we have learned in the efficiency of the PV cell, when there is something called P in equals to L into A. You guys remember L into A, we multiplied the L into A, that L was the solar insolation. We are actually learning today how this solar insolation is counted or collected from the sun. এটা আমরা কিভাবে সান থেকে কি হিসাবে বের করি, we will try to understand the calculation. So, accumulated effect of all wavelengths together is insolation L. So, insolation L means this graph is for unit wavelength. Now what they have done here, they have taken the area underneath it. By taking the area underneath it, we are actually getting the total insolation power, solar insolation L. Okay, that is why they integrated means actually they are taking the smaller values then add them up. If you see here, যদি এখানে দেখেন, suppose first I am ওকে, সবাই শুনতে পাচ্ছেন, দেখতে পাচ্ছেন তো?
জি স্যার।
জি স্যার।
So the topic where today we are proceeding with the solar insolation. Before this connection, we went to learn the topic that is called spectral irradiance. Spectral irradiance actually means that the power per unit wavelength, the amount of power you are getting per unit wavelength. But you don't only want the power for unit wavelength. You want the power for total wavelength. So that is why what you do, you multiply the solar irradiance with the wavelength. Now what you do here, এখানে আপনি যে কাজটা করছেন, আপনারা কি এই ক্যালকুলেশন গুলো দেখছিলেন কিছু?
না স্যার, এগুলো দেখা যায় না।
অসাধারণ। আচ্ছা দেখেন, so the solar insolation we want to calculate here by the means, দেখেন, suppose in this axis, in the y axis there is something called the irradiance. Here this is the wavelength. So whenever you are multiplying the irradiance, with wavelength, you are getting the solar insolation. Okay, now whenever, if the graph is not that simple, suppose it is not linear, then what you do, you take a smaller value here for a respective solar irradiance. Okay, so then you calculate for every region, for each point, then what you do, you add them up, and for adding them up there is this integration sign. Okay, for smaller values you get the irradiance for each value. So multiplying these two terms, you get the solar insolation here. That is what I want to tell you here. Okay, by multiplying the spectral irradiance with respect to wavelength, you are getting the solar insolation. Now, solar insolation term is very familiar to you because you have used this term in the sizing of PV cell and the solar efficiency. If you remember, kilowatt per meter square, 1 kilowatt per meter square. If you multiply it by the area, then you are getting the solar insolation. So that is the important part. Now if you see that why this wave, if I see the unit is a kilowatt per meter square per unit wavelength, but the unit here is the kilowatt per meter square. So why wavelength is gone, sir? Because you have multiplied the spectral irradiance with wavelength. That is why the unit wavelength is gone. So this power is for the total region here, total region এর জন্য you have got the power. Okay, solar insolation is that the accumulated effect of all wavelengths together is insolation. সবাই কেটে কেটে শুনতেছেন না একজন?
না স্যার, আপনার কথা ক্লিয়ার শুনি।
আচ্ছা, ওকে।
স্যার এখানে ঠিক
Okay.
আছে স্যার।
So this is called the solar insolation. Okay, আমি স্লাইডটা বড় করতেছি না, নাহলে আমি দেখতেছি না আর কি নেট কানেকশনটা আছে কিনা। আচ্ছা, এখানে আপনারা দেখবেন, স্পষ্টই দেখবেন। Now if you look carefully, this graph is for the spectral irradiance versus wavelength. Now I want to show a graph that is solar insolation versus time. যে বলতেছেন কেটে কেটে আসতেছে, আপনার নেটের সমস্যা, আপনি একটু বের হয়ে আবার ঢুকেন। হ্যাঁ, বাকিরা শুনতে পাচ্ছে ক্লিয়ারলি। থ্যাংক ইউ। যদি সবাই কেটে কেটে শুনেন একটু নক দিবেন। আচ্ছা, so this is solar insolation versus time. This thing actually means that the solar power is not always same over the 24-hour period. This is very simple because the solar insolation, the solar power is not always identical throughout the time, because you feel much hot during the noon rather than the night, because at night there is no sun. Okay, you feel the sun much more during the noon rather than the afternoon, because at the afternoon sun is setting, so the power is not that much high. So that is what I want to show you here. But remember, whenever you are seeing this graph, this is the solar insolation versus time. This is the solar insolation versus time, and this graph is the spectral irradiance versus wavelength. Though these two graphs are very much identical, but these are not identical graph. These are very different graph. This graph is spectral irradiance versus wavelength. From this graph we get the solar insolation, and this graph is the solar insolation versus time, and this is we are drawing here for 24-hour period or 12-hour period, it doesn't matter, because do we actually need to draw it for 24-hour period? Absolutely no, because sun is not there for 24-hour period. Sun is only there for the half of the total day. Now if I draw here to দেখেন, suppose this is the solar insolation L, this is my time T. Suppose this is 6 a.m. Suppose this is 12 p.m. দুপুর 12টা. Suppose this is 6 p.m. So by the common sense, we know that sun rises at 6 a.m. or near about 6 a.m. Sometimes 5 a.m. sometimes 4:30. So I'm taking a general value for 6 a.m. Okay, I'm not going to the rigorous one. The sun is rising at 6 a.m. So the power will also rise, and whenever it is 12 p.m. at the noon, okay, I'm taking that the power is peak at that point. Then after that time, power is also going down, and at 6 p.m. sun is set. Sun is set down. Now for my 12 p.m. noon, I'm getting the peak power. This is the graph that I have shown you there. This is my peak power. Now what they do, if you remember that there is some term called the energy. Okay, energy. What is the energy? If you multiply your power with respect to time, then you get the energy. Now we will learn an important term which is known as the energy, and that energy is called the incident energy. Okay, that energy is called the incident energy. Okay, so to দেখেন 2 মিনিট পরে দেখাচ্ছি. So this is actually the insolation variation in a day. Okay, the insolation is varying with respect to time. Time এর সাথে সাথে ইনসুলেশনটা ভ্যারি হচ্ছে। দেখেন, insolation varying with time. 6 a.m. it is getting large, and now you see that the solar insolation in the y-axis, time is in the x-axis. Suppose the time is taken as unit as hour. So if you multiply this L with respect to h, then what you are getting the area underneath it. Whenever you are multiplying the insolation with time, then you are getting the area underneath it. That area underneath is my h, and the unit of h is, you remember what is the unit of L? You guys remember, this is kilowatt per meter square. Kilowatt per meter square. Now you are getting the area which is noted as h. You are multiplied it by hour. So what will be the area? What will be the unit of h? Can anyone tell me what will be the unit of h? এটা হবে এটা হবে kilowatt hour per meter square, because you multiplied the hour. So it will be the unit will be kilowatt hour per meter square. That h is the energy. This energy is called the incident energy of sun. By that incident energy, you come to know that how much of energy you are getting in a certain location and in a certain time of the day or in a total of the day. মানে total আপনি পুরা দিনে কতটুকু পাওয়ার পাইতেছেন। So this is what they have calculated here. Now আমি যদি একটু দেখাই দেখেন, for incident energy H, this is the incident energy H. I want to find a, you know, that the standard amount to express everything. I want to find a standard amount to express everything. You see that the area under that curve was our H, the incident energy. Now I am taking a line which is called the standard insulation line, like this dot dot dot. This is my standard insulation line. And under that area is this. So if you are taking that area for H hours of time, then what you will get, if you multiply, if you take that standard insulation for H hours, then 1 kilowatt per meter square into H, you have multiplied the standard solar insulation into time, then you get the H kilowatt hour per meter square. If this is equivalent energy, if this is the equivalent energy with respect to H, then H equals to capital H kilowatt hour per meter square per day. That means by knowing the value H, whenever I will do the math, it will be more clear to you. In the next class, we will do the math. This H is actually giving you an idea that how much energy you are getting from the sun. Okay, the equivalent hour. Okay, hour দিয়ে হলো আপনি বুঝতে পারতেছেন যে how much time you must need to operate your PV cell. How much time you need to operate your PV cell. The PV cell to operate করার জন্য কি টাইম লাগবে? Now suppose that let WH load be the required energy. WH load means the energy that is required for a PV cell to produce, the amount that is required by your own home, by your house. WH load, this energy is required by you. Now as this energy is required by you, if you divided it by H, is the peak power required from PV. If you this WH load is actually means the energy that is required by you. ঠিক আছে, মানে that means আপনার সারা দিনে কি পরিমাণ পাওয়ার দরকার। WH load means that how much energy you need the whole day in 24 hours. So if you divide that WH load divided by H, is the peak power that is required from PV. That is the peak power required from PV. Why these things are important, sir? What are we actually getting from here? These things are important in order to design your PV cell. That what will be the area, what will be the length, what will be the weight, how many series connection you need, how many parallel connection you need. These are very important terms in order to find those parameters. That is why I'm giving emphasis on it. আজকে আমরা theoretical জিনিসগুলাই বুঝবো. So whenever WH load is actually the energy, whenever kilowatt hour. So whenever you dividing it by hour, the hour that you taken for the standard insulation, that how much time it needs to operate my PV cell. Whenever you divide by it by H, then you get the peak power required from the PV. So suppose I'm giving you a scenario. Suppose that you are in your house, you are operating TV, you are operating your Wi-Fi, you are operating your laptop in various electrical devices. But there is a certain time at which time two of your fans are on, two of your lights are on, your laptop is operating, your Wi-Fi, everything is operating. That means that is the peak. Suppose that peak is 30 watt. Whenever my PV cell can produce that 30 watt at that peak time, that means my PV cell will be able to provide electricity in all of my other times. Okay, because he's giving me power at my peak time. So in other times it will be very easy for him. He is prepared for the worst. আপনি ওয়ার্স্টের জন্য প্রিপেয়ার থাকবেন যে এত অ্যামাউন্টের জন্য আমাকে প্রিপেয়ার থাকতে হবে, দেন ইউ ডিভাইস উইল বি সেফ। ওকে, ইট ইজ এই কারণে হলো আমাদের ইম্পর্টেন্ট। সো নাও I hope you understand the incident energy. This incident energy is nothing but the multiplication of the solar insolation and time. By the multiplication, you are getting the energy that we are getting from the PV cell. and the energy we are getting from the PV cell and the energy that we demand from the how that we require that we require will be accumulated. We will do the math and we'll proceed that then we'll understand then what will be the size, what will be the series connection, what will be the parallel connection, how many series cells, how many parallel cells are needed. Okay, this is the combination that is needed. Now we're going to the last slide, that is factor affecting H. Factor affecting H means that the factors that are affecting the incident energy. In our course, we will not go to the details of each topic, but we will know the each topic. We will not go to the details, but we will know the each topic. So first comes the factors affecting H. First comes the geographic location. Geographic location means that suppose there is called latitude, there is longitude. You have যে দ্রাঘিমাংশ অক্ষরেখা এগুলো পড়ছিলাম না, latitude, longitude. So these things, because as you are seeing that the solar insolation is something like this, but solar insolation is not like this in Sahara Desert. Solar insolation is not like this in Iceland, because in Iceland the sun doesn't set. So if this curve is actually designed for Asian conditions like Bangladesh, India, Pakistan, etc. Because we follow this type of things, because it is very normal for us that the sun rises at 6 a.m. and it sets at the 6 p.m. But in Canada, in Sweden, in Scandinavian nations, sometimes the sun goes down at 10 p.m. This is very much unusual for us, and we can't think about it. But then the graph will not look like that in that region. So these things are actually, the incident energy H is actually 100%. 100% depends on the location of the area. So the solar cell you're designing for your roof, for your house, will not be compatible with your friend in USA or not compatible with the relatives in England. Okay, if any relative from the England giving you a solar PV cell, you can't operate it because they are not compatible with it. Sometimes you will see that the charging devices, they can আপনারা যখন অনেক মোবাইল রিভিউ দেখেন, the charging devices in our country, in Asian country, and the charging devices in USA or the England are not same, because the ratings are not same. In our country, it is operating for 50 hertz condition, but in that Western countries, it is operating at 60 hertz 60 hertz AC connection. So these things are not similar everywhere. So that is why the factor that is affecting, one of the most important factors that is affecting incident energy is the H, geographic location. Okay, geographic location actually determines the shape of our solar insolation curve. Then the collector orientation. Collector orientation is another important thing, that is that the how my PV cell is situated at roof, at how much angle. Suppose I have shown you here, suppose my PV cell, suppose sun is not always at a certain direction, whether it is actually the earth is moving, whether we see that the sun is sometimes here, sometime here, sometime here, sometime here, sometime here, sometime here, sometime here. So the rays are coming like this from the sun. So if in the previous class we have seen that the angle is very important for the efficiency of the PV cell. So if my cell is like this, or if my cell is like this, or if my cell is rotated like this, so there is certain angle with respect to here, there is certain angle. Okay, that angle is noted by, these terms are very important. This angle rotated is by beta. So this angle is beta. So with the angle beta changing, the insolation energy you are getting from the PV cell is also changing. So this is very important. These things are very important. Collector orientation, or the orientation of the PV cell, that is very important. Collector tilt angle. Now, time of day. Okay, time of day. What is the time of day? Because you can see in this graph that the graph is not always same in every direction, in everywhere. Because at 6 a.m. you are getting the power you are getting is very low. The 6 p.m. power you are getting is very low. At 12 p.m. the power you are getting is very high. The power is not always same everywhere. Power is changing because it depends on the time of the day. That is why this you will see in the upcoming class, you will see something called the storage devices. Storage devices are very important as well. Okay, so storage devices are very important as well. With the help of the storage devices, you will be able to operate your PV cell at night as well. So here comes the time of the day. This is also very important. Then comes the time of the year. This is also important because now in Bangladesh it is summer, so the sun is scorching hot. But whenever it is winter, the sun will not be scorching hot. So the PV output you will get from the sun or your PV cell will not be the same in the July of 27 or to the December of 27. These 2 days the power will not be the same. So this is very important. Sometimes it is raining, cats and dogs. The rain is very heavy, so the power will not be the same at that day. So what I want to tell you that the variable number is very high, but what we have to do, we have to simplify, we have to generalize those variables in order to get a clear short output. Okay. So time. Then comes the atmospheric conditions. Atmospheric condition means there will be like clouds, water vapor, gases, etc. Atmospheric condition is directly involved in the condition of the PV cell. Suppose if my PV cell, this PV cell is suppose 2 days old and 2 days old. Okay, now this PV cell, suppose this is 2 years old. So by common sense, you know that this cell or this cell will not give you the same power. This cell will give you the less power because it will be affected by the weather. There will be some, there will be some effects by the rains, by the dust around it, by the clouds around it, etc. Okay, as that if there is huge amount of dust, then the PV, that the solar ray can't penetrate, then it will give you less power. So these things are very important. এই জিনিসগুলো এখানে লেখা আর কি, বুঝছেন? These are the very topic that are very common sense topic, যেগুলো common sense দিয়ে বোঝা যায় যে clouds, water vapor, gases, এই জিনিসগুলো, these things hugely impact our PV cell. Okay, so I hope you guys understand the topic that is called the solar insolation and the insolation variation in a day and how this works. In the next class, we will do a math with the help of these parameters and we will try to design a proper PV cell for ourselves. Okay, thank you everyone. আমরা এখানে আজকে ক্লাস শেষ করতেছি।